So I can speak to them. Hello? Are you able to hear me? I don't know anybody's name. Hello, 11th year students. Are you able to hear me? Are you ready? So, they can speak. Hello? Anybody from 11th A can able to hear me? Hello? Hello? No, they are not able to. So it is an interactive thing actually. So problem I feel
They can add, they can ask message in the chat box. So you will left corner, the top button here, that is the chat window. They can post the questions there.
Okay. So all these things they know well.
So you can just tell them.
Okay. So you better talk to one of them, then you can do. Anybody is able to hear me? How much time will it take to go from home? And it should be somewhere here. కనిపించదా వేసిన బ్యాటరీకి కనిపించదా
Light,
light ఇక్కడ లైట్ లేదు
but this reflection.
సో అది కండెన్స్ క్లోజ్ చేయాలంటారా
Exactly. Once it starts going, you continue with the copy. Ask the questions and ask.
So at least if one student is interacting.
5 viewers are there.
Okay, they are not able to talk back to
Right now, there is talking back.
Hello, can you able to hear me? In the last class, we had the whole class, which what is gram atomic mass, what is the gram mole, and what is the relation between the gram mole, gram molar volume, gram atomic weight, and all. And today we have to calculate certain molecular weights of certain compounds. So calculate the molecular weight of this following compounds. I'll give you some examples. Then after that you can do on your own. So first one I'll give you CH4. Nothing but methane. Methane. In methane, there are 4 hydrogens. Means atomic mass of hydrogen is 1. So 1 into 4 is equal to 4. And this 1 carbon, 1 into 12 is nothing but 12. So the total of the atomic masses becomes 16. So molecular weight of methane is equal to 16. Molecular weight of methane is equal to 16. So in other words, we can say that molecular weight is the sum of the atomic weights of all the constituent atoms present in the molecule. We can calculate the molecular weight various compounds which we generally come across in laboratory. And I'll take sodium hydroxide, NaOH. As we know pretty well, sodium atomic weight is 23. Na is equal to 23. And oxygen atomic weight is 16. So the total becomes 40. So the molecular weight of sodium hydroxide is 40. Same manner, H2SO4. There are 2 hydrogens. So 2 into 1, sorry, again 1 into 2 gives rise to 2. And sulfur, 1 atom, atomic weight is 32. So 32. And there are 4 oxygens, 4 into 16, nothing but 64. And the total becomes 98. So 98 is the molecular weight of sulfuric acid. Same manner you can calculate HNO3, nitric acid. There is only one hydrogen atom, so 1 into 1, nothing but 1. There is one hydrogen atom, so nitrogen is 14, 1 into 14, nothing but 14. And there are 3 oxygens, 3 into 16, nothing but 48. And total it is 5 plus 8, 13, and it is 63. Molecular weight of nitric acid is 63. Similarly, calculate the molecular weight of sodium carbonate. Formula CO3. Are you able to follow me? If you are able to follow me, please let me know. Are you able to hear me? No. Okay. Sodium carbonate also I'll show you. Na2CO3. There are 2 NAs. 2 into 23, nothing but 46. This 1 carbon, 1 into 12, equals to 12. 3 oxygens, 3 into 16, nothing but 48. And total is 1 oxygen. So the molecular weight or simply molecular mass of Na2CO3 is equal to 1 oxygen. Equal to 1 oxygen. Same manner, calculate the molecular mass or molecular weight of the following compounds. This is the question of you. Calculate calculate the molar masses of the following compounds. In the KCl will be potassium chloride, ammonium phosphate, NH4 thrice PO4, potassium sulfate, K2SO4. I'll give the numbers 1, 2, 3. Then number 4, calcium hydroxide, CaOH twice. 5, ammonia, NH3. 6, H2O, water. So this you should do on your own and find out the answers, molecular weights of all these compounds. Once if you finish this, then I'll give you some more problems basing on the mole concept, and I'll explain 1 or 2 problems, and then you need to do on your own. In case if you have got any doubt, and please message me. You can also do messaging. I can see on the computer if you can message. You can also talk to me. Okay, fine. Then let us have a look at the other problems based on calculate the volume occupied by 1 mole of NH3 gas at SPP. This is the question. This I will say how to solve by applying the mole concept. And according to the mole concept, just 1 mole of any gas, 1 mole of any gas at SPP occupies 22.4 liters. And now, ammonia, we have to see the molecular weight. NH3 molecular weight is equal to 17. Therefore, 17 gram of NH3 is equal to 1 mole of ammonia. Therefore, the volume occupied by 1 mole of ammonia NH3 is equal to 22.4 liters. It's a direct question I will give you. Direct application of the GM definition. 1 mole of any gas at SPP occupies 22.2 liters. Now, I'll give you another problem. Calculate the volume occupied by 51 gram of ammonia. 51 gram of ammonia. So as we know pretty well that molecular weight of ammonia is 17 So, therefore, 17 gram of NH3 ammonia is equal to 1 mole, and which occupies 22.4 liters. Therefore, 51 gram of ammonia occupies how much water? So 51 by 17 into 22.4 liters. So 3 into 22.4 will give the final volume occupied by 51 gram of ammonia. Next problem. You are given 25 gram of sodium carbonate. 25 gram of sodium carbonate. How many moles of Na2CO3 do we? Very simple to do it. Just calculate the molecular weight of sodium carbonate divided by the given amount. You get the number of moles. I would like to say Na2CO3 molecular weight will be divided. So that we have already calculated. So sodium is 23. So 2 into 23 is equal to 46. And 1 carbon, 1 into 12 is nothing but 12. 3 oxygens, 3 into 16, nothing but 48. And total becomes 106. So if I take 106 gram of Na2CO3 is nothing but 1 mole. 1 mole. The given mass is 25 grams. So 106 grams is 1 mole, 25 grams of Na2CO3. How many moles? So 25 by 106, that gives the number of moles of sodium carbonate in 20 grams of sodium carbonate. Next, another problem. You have to simplify this and find out the answer. I'm not going to do the simplification. You need to do on your own. Otherwise, I'll teach you how to see the log tables, then you follow the lag tables, and then from there you need to do on your own. So if you come in contact or if you can interact with me, then only I can teach you the log tables. Is there anybody?
Yeah, they can post in. We are unable to read because the name was line. Okay, that is done. And marker was right. Okay. Maybe in handwriting a little bit weaker you can read. But yeah, that's
Okay. So will you be ready with log tables with you? There are two members. One is logs and the other is anti-log table. Then I'll teach you how to see the log table so that we can simplify the multiplications. So two more problems I'll teach you and then we'll go for the log tables. So calculate the mass of 1 mole of calcium hydroxide. Calculate the mass of 1 mole of CaOH twice, calcium hydroxide. And every time they may not be giving the formula, they will just give the name. You know how to write the formula. I already taught you how to write the formula of various compounds. So hereafter I won't give you the formula, just I will give you the name. You need to write the formula on your own and then calculate the molecular mass. So 1 mole of calcium hydroxide, I'll write just in words. Calcium hydroxide. So unless you know the calcium hydroxide formula, you cannot calculate. So anyway, I am giving you CaOH twice is calcium hydroxide. So the calcium atomic weight is 40. 1 into 40 is 40. And there are 2 oxygens and 2 hydrogens. So 2 into 16 is nothing but 32, and 2 into 1 is nothing but 2. So it is 74 is the calculation. So 16, 17, 24, and what is 74? Yes. 74 is the molecular mass of calcium. Molecular mass of CaOH twice is equal to 74. I hope by this time you know how to calculate the molecular weight of various compounds. And as per the definition, you can say that molecular weight of a compound is nothing but the sum of the atomic weights of all the constituent atoms present in the molecule. So the same thing you need to apply, and you must be aware of the atomic weights of the various elements present in the molecular formula. Then only you can calculate on your own. So please look at the atomic weights as and when it comes, and definitely they will be given in the question paper. At the same time, we must also get acquainted with the very common atomic weights. Okay. Then we go for next problem. Calculate the number of molecules present in 0.44 grams of carbon dioxide. I'll write the problem on the board. Calculate the number of molecules present in 0.44 gram of carbon dioxide. Again, nothing but molecules. Here we need to know how many molecules will be there in 1 mole of a substance, and according to Avogadro's number. So what is Avogadro's number? It is the number of structural units present in 1 mole of any substance, whether it is gaseous or a solid substance. So if I take 1 mole of CO2, and it constitutes n number of CO2 molecules, where n is nothing but 6.023 into 10 power 23, which is nothing but Avogadro's number. So as we know that the molecular weight of CO2 is nothing but 1 carbon, nothing but 1 into 12, 12, and 2 oxygens, 2 into 16, nothing but 32. And so the molecular weight of CO2 is equal to 44. So it means 44 grams of CO2 is equal to 1 mole. Is equal to 1 mole. So 1 mole consists of 6.023 into 10 power 20. Means now 44 grams of CO2 contain how many molecules? 6.023 into 10 power 23. Up to this is just nothing but the mole concept, in which 1 mole of any substance contains 6.023 into 10 power 23. We have just calculated the molecular weight of carbon dioxide. So knowing the weight of carbon dioxide of 1 mole, which is nothing but 44. So the 44 grams of carbon dioxide consists of 6.023 into 10 power 23 molecules of carbon dioxide. Now the given weight is 0.44 grams. So I can write 0.44 gram of CO2 contain how many molecules? So it just nothing but 0.44 by 44 into, I'll write n, where n stands for the Avogadro's number. So again I want to ask you to simplify on your own. I am not going to do the simplification part. It's just simple, very simple, that you need to do on your own. Okay? So I hope you got what I am meaning. So I'll write it clearly: 0.44 by 44 into n You know, n is nothing but 6.023 into 10 power 20. You just write in terms of n in case it is asked there. So the numerical value just need to multiply with 6.023 into 10 power 23 and find the final answer. Hope you are following me. And welcome. We are starting 2 minus please. So I'm not getting any messages. So.
I'm getting.
You're getting them.
Yeah, I'm hearing fine.
Okay, yeah, fine. So next one more problem I'll take up. Calculate the number of moles of magnesium present in 1 kg of it. I'll write the problem. Calculate the number of moles of magnesium present in 1 kg of it. So here simply we need to know convert into grams. So 1 kg we know it is nothing but 1000 grams. Right? Calculate the number of moles of magnesium present in 1 kg of it. So here's nothing but we are taking magnesium 1000 grams. So what is the atomic weight of magnesium? Atomic weight of Mg is equal to 24. Why? Because magnesium atomic number is 12. Usually the atomic mass is twice to that of the atomic number, or it may be a little bit more, but that value will be given here. Mg atomic weight is 24. So just number of moles you get weight by molecule. Number of moles is equal to number of moles is equal to weight by molecular weight. This is the part we need to add. Molecular weight, MOL, just simply weight. So weight is given as 1000 and molecular weight is 24. Then simplify it. Find it. 1000 by 24. Again, I am asking the same. I am not showing how to simplify. 1000 by 24, simplify and get the answer. But you must do it on your own. If you can simplify the normal way, fine. Otherwise, I'll teach you how to do the simplification with the help of log tables. So once if I'm sure that you are with log tables and what to do, and I will teach you that. And please let me know. Okay. So that one more problem I know. How many atoms of sulfur are present in 64 grams of sulfur dioxide? How many atoms of sulfur? How many atoms are present? How many atoms of sulfur? How many atoms of sulfur? How many atoms of sulfur are present in 64 grams of present in 64 grams of SO2 sulfur dioxide. So very simple again. I already explained you the term atomicity. Atomicity is nothing but the number of atoms present in a molecule. Here in SO2 means one molecule of SO2 contains one sulfur atom and two oxygen atoms. So this is one molecule of sulfur dioxide. Be careful, not all. One molecule. One molecule of sulfur dioxide contains one sulfur atom and two oxygen atoms. Now we need to identify how many molecules of sulfur dioxide are there with us. So here it is 64 grams is given. So we need to calculate the molecular weight of sulfur dioxide. Sulfur atomic weight is 1 into 32, nothing but 32. There are two oxygens, 2 into 16, nothing but 32 again. So the molecular weight of sulfur dioxide is 64. So 64 grams of SO2 is nothing but 1 mole of SO2. So if there are 1 mole, so 1 mole contains n number of molecules, where n is nothing but Avogadro's number. So what we have is just only n number of molecules. So if I have n number of SO2 molecules, and we have only one sulfur atom in one SO2 molecule, so it is very simple. The number of S atoms in 64 grams of SO2 is equal to N. So that's how we can understand. Once again, please have it here. The gimmick is what you need to understand is one molecule of sulfur dioxide contains how many sulfur atoms? So one sulfur, two oxygen atoms. Oxygen atoms is not asked, but only we need to look at sulfur. So next thing we need to identify how many number of molecules are there. So how can we understand 64 grams is equal to how many moles? As we know, 1 mole is equal to Avogadro number of molecules. So when we know the molecular weight of sulfur dioxide, which is nothing but 64, so 64 grams of SO2 is nothing but 1 mole of SO2, which contains n number of molecules. So we can say one SO2 molecule consists of one sulfur atom. So n number of sulfur dioxide molecules contains n number of atoms. That is nothing but sulfur atoms. I hope it is clear. So whenever it has been asked to find out the number of atoms, you must be clear about the atomicity. How many atoms of a particular element are present in one particular molecule. Then after that, we need to identify the number of molecules. So then multiply it, you can get the total number of atoms present in that particular substance. Yes, that's all we can do. So next one more problem we go for. Calculate the mass of one atom of hydrogen. I'll write it. Calculate the mass of one atom of hydrogen. One atom of hydrogen. Calculate the mass of one atom of hydrogen. So here what he is asking is, as we know, atomic number of hydrogen is 1. So atomic weight of hydrogen is nothing but atomic weight of hydrogen of H is equal to 1. So what is this 1? What is nothing but 1 unified mass or simply 1 kU, atomic mass? So here he is just asking you, what is the weight of one atomic mass? So how do we calculate this one? Let's have a look. So grab atomic mass by Avogadro's number. So what does it mean? See, as we know that 1 mole of substance, 1 mole of any substance consists of Avogadro number of molecules or atoms, whatever may be the structural units. So then, if you want to calculate weight of one particular atom, that's just simply the atomic weight by Avogadro number will give the atomic weight of one particular atom of that particular substance. So as we know that atomic weight of hydrogen is 1, so if I take 1 gram of hydrogen, it's nothing but 1 mole of hydrogen atoms. As we know, 1 mole of hydrogen atoms means it's nothing but 6.023 into 10 power 23 atoms. So therefore, the weight of H atom is equal to 1 by 6.023 into 10 power 23 gram. So that becomes somewhere as 1.66 into 10 power minus 24 grams. Calculate it, find out. Tell me how much. Yes, it is around 10 power 24 minus 24 grams. You will get the answer. Or in case if you want to express in terms of 1.66 into 10 power minus 27 kg. Sometimes you ask in grams, sometimes kg, and whatever it may be, is there. So I would like to explain the same thing once again. It's very simple. Here just we are calculating the atomic weight of a single atom of a particular substance. Just how can we calculate means, just to recall, what is a mole? Say, gram atom, or simply gram atom. Gram atom is nothing but atomic weight expressed in grams. Atomic weight expressed in grams is nothing but gram atom. So, atomic weight of hydrogen is nothing but 1. So, if I take 1 gram of hydrogen, is nothing but 1 mole of hydrogen atoms. 1 mole of H atoms. So, 1 mole of H atom is nothing but Avogadro number of atoms. That is nothing but N. So, simply we can also remember the formula weight or mass of one atom is equal to atomic weight by Avogadro number. Avogadro number. Or simply 6.023 into 10 power 23 is nothing but Avogadro number. You take any element. If you want to find out the atomic weight of a single atom, it's nothing but atomic weight by Avogadro number, which is the atomic weight of a single atom. So in case of hydrogen, it's nothing but 1.66 into 10 power minus 24. Okay. So then one more very simple basic problem. These are very simple and basic problems. And I'm giving you these problems out of the book. And once you start doing the textbook problems, then you will find a little bit more difficult. So first you get acquainted with this terminology as well as the way you need to solve. Then definitely you can do on your own the textbook problems. In case if you find any difficulty while doing your textbook problems, you just let me know which problem, then the same problem I'll explain you on the board in the same way. Okay, at least 10 problems today, 1 to 10 from CBSE textbook you start doing, and let me know how many of you able to do on your own the first 10 problems in CBSE textbook. And in case if the concept, see, if the problems are given on percentage, mass percentage, which I have not taught, don't touch them. Just only touch the problems according to mole concept, only mole concept problems. Touch only the mole concept problems in the calculation of atomic weight or mass per weight, only those problems. Right? So then once this is over, then I will talk about the percentage composition and then empirical formula and then the next. Okay. So first we get acquainted with the mole concept and the problems. Then we go for the next level. Okay. Same. Why don't we problem and calculate this? Calculate the mass of one molecule of oxygen. Here previously I asked one atom of hydrogen, now I am asking one molecule of oxygen. Calculate the mass of one molecule of oxygen. Is one problem. Do it on your own, and another four problems you do on your own. Calculate the number of molecules. Calculate the number of molecules in 11.2 liters of nitrogen gas. At STP, standard temperature and pressure. And one more problem. Calculate the volume of of 20 gram of hydrogen gas at STP. So once you finish doing these problems, then I will give you the problems based on chemical equations. So I can give you some introduction about what is a chemical equation and the stoichiometry of a chemical reaction. So first of all, to do this whole concept today, and I will send you some problems by mail, and tomorrow I will give you about the stoichiometry and about the reactions. Stoichiometry of chemical reactions we need to talk, and then so basing on that the problem will be like this. I'll give you some amount of substance and a basic reaction. So decomposition of potassium chloride gives so amount of chloride and oxygen. Then you need to identify how much of oxygen and how much of potassium chloride is formed. So for which you need to have the idea how to write the balanced chemical equation, and then only you can do the problem. So that we'll do it tomorrow, and today I'll send you some more problems by mail in case it is possible. So then start whole concept only. Don't go beyond whole concept today. Just only do the concept and be aware of the four definitions of what is gram atomic weight, what is gram molecular weight, what is GMV, and what is Avogadro's number, and the relation between these four terms. Right? And you know one atomic mass unit, the weight, already I have given you. What is the one atomic mass unit of, say, it's nothing but a atomic weight of hydrogen. So that's one important thing. Just know the relationship between the gram atom, gram molecular weight, Avogadro and GMV. Definitions related to mole concept. And tomorrow I'll show you how to write a chemical reaction, and then we can do the problem basing on stoichiometry. Okay? Bye. Yeah. Yeah, and my email address, you should know that. What is my Gmail? I'm very cool in that. You will email
VHN user.
Yeah, immediate. See, my email address is totally different from the ID what you have given. So, Uday BT My email address is udaybt at
DPS Uday Bhaskar and DPS Uday and
Uday that one connected. Yes. So what was the spelling here? UDA by Uday, BHA and you?
yes.
Yet
DPS
yet the DPS
yes second record SCCUN
yes you
dot
.in. Okay. So I'll read my email address to which you need to send your problems. That is udayabhamu at dps. Any dot? dps
Secunderabad dot in.
dps dot no dps secunderabad dot in.
Next.
Then the same thing you can send it by mail, I hope.
Yeah, we don't have their ID.
No, then how come they are able to?
Like direct link to their website. They are opening everything.
They're able to see that. Is it so?
Like no.
Can I?
Well, people have.
Can I have a look at what I got? The same thing.
You can ask them to send feedback by this website.
That's fine. Feedback. I see. I want to see my teaching how it.